takeoff. 1, Resource speaking.
Pressure coming here, pressure coming.
We're 1.5 below.
Stand by, 2 dives here, boys.
We're looking at 10.5 to 42.
Welcome, podcast listeners, to another edition of my sailing podcast. Thanks so much for listening in. And before we get things underway this month, a big thank you for all your comments on last month's pod. There's been a lot of love for Jimmy Spittle. So if you got in touch, liked, commented or subscribed, as ever, thank you. It's much appreciated. Any interaction, it really means a lot. So what have we got for you this month? This edition of the podcast is a little different. It's another bumper 2-part pod, and with all the action hotting up in the America's Cup, we thought we'd push the boat out and try and talk to all 4 of the design teams from each of the Cup's teams around the world. We've all seen the footage online of the new AC35 monohull zipping around on their foils. They look magnificent. So this month we're lifting the bonnet on the new Cup class, getting the design lowdown from each camp. In the interest of transparency, we didn't travel to every design office. I spoke to the 2 European teams in person, travelling to Sardinia to chat to Luna Rossa and just across the Solent here to talk to Team INEOS UK. But we had much appreciated help. We sent questions to the Defender, to Emirates Team New Zealand's design team in Auckland, and had local assistants recording a telephone interview with the American designers based in Santander, Spain. So before we get underway, a big thank you to everyone involved in making this happen. To the 4 design chiefs themselves for their valuable time at such a crucial moment in the whole Cup process. A huge thank you. It's a fascinating listen. We really get an understanding of how this new Cup class is shaping up. The design rules, the hurdles and challenges. It's really enlightening. I hope you all enjoy the time I spent with the design teams of AC36.
We went ahead with this concept having only ever tried it on a simulator.
The stakes are pretty high because some people get it right and some people get it wrong.
From those simulations we were, I must say, right from the beginning, very confident that it would work.
We kick things off, of course, with the Defenders and Emirates Team New Zealand's design chief, Dan Bernasconi. Dan was a key figure last time around, leading the team that built the AC50 that foiled New Zealand to victory in the Great Sound of Bermuda. I started by asking Dan how things were shaping up with the team in Auckland.
We're really excited about the event coming up in Cagliari and the one in Portsmouth following that. We've watched with a lot of interest what other teams have launched with, and I think it'll be pretty exciting for everyone to see how the boats go against each other. We're feeling good. We've had a lot of time on the water, but on the other hand, our boat goes on a ship pretty soon, and whilst we're sitting on a ship, then all the other teams will be in Cagliari training and improving. So we've had to get a bit of a head start, and we'll see how we go when we get there. But yeah, really looking forward to it.
Let's just start the podcast, Dan, with a quick recap. And as Defenders, you specifically were instrumental in laying out the design criteria of the boats for AC36. Can you give us a quick summary of what the teams need to be building? Give us a quick summary of the AC75.
Sure. So the AC75, it's a 75-foot long monohull. The hull length 68 feet, and then a 7-foot bowsprit. There's 2 foils which are supported on either side of the boat by composite foil arms, but the foils themselves, they're ballasted to provide some stability and to increase the overall weight and riding moment of the boat. And the 2 foils can be raised up and down independently depending on what tack you're on. Then driving the boat is a rig which is a new type of rig for America's Cup, which is a D-section spar with 2 a double skin mainsail coming off the back of the D section to provide a sort of solid cross section with a hoistable sail, which sort of combines the efficiency of a solid wing with the sort of convenience of being able to leave a mast in the boat when at the dock or at a mooring. And single rudder, a range of head sails, including a Code Zero flown off the bowsprit. The teams are pretty much building all of their boat. The only supplied components are the foil arms. They're the same for all teams and being built by Persico in Italy. And the reason we made those supplied components is that they're pretty complex structural components, and we didn't think that it would add a lot to the competition for each team to be developing those independently. They're complex to build, but in the end, they're mostly out of the water, so not really providing that much differentiation between one team and another. So we made those one design components and supplied components so that teams can basically concentrate on the areas that are a lot more interesting for R&D and development, which is the hull shape, the foils and rudder, and the rig and sails.
We've never seen a boat of this kind designed to this degree before. Having come up with the concept, how pleased are you personally to see all four teams outsailing this concept, foiling, reaching good speeds from your original design?
Well, it's a hell of a relief to see teams successfully getting a boat on the water and seeing that the boat works around a racetrack. Only seen one boat at a time so far, but really looking forward to seeing how the match racing goes. So yeah, we went ahead with this concept having only ever tried it on a simulator, but I think it's been validated in real life that it's a really exciting boat to sail. The sailors love it, really good performance, and I think it's going to be exciting for spectators as well.
We'll hear plenty more from Dan a little later. But before we do, we're going to catch up with the official challenger of record, Italian team Luna Rossa, specifically their design coordinator, Martin Fischer. Martin has a strong pedigree in foiling yacht design, with a raft of design credits to his name. So we took off down to the team's base in Sardinia to find out how things were shaping up. Well, Martin, thanks for joining us. It's not long to go until the first of the World Series events here in Sardinia, of course. And there's a real sense in the cup, isn't there, of the ticking clock that, actually time is moving very quickly. How are things going at Luna Rossa?
Well, time is definitely, as you said, ticking, and it's probably the biggest asset in any cup campaign. So time is always running out. And as of Luna Rossa, well, we think we're on track. Of course, I guess as all the other teams, we also have our difficulties or have had our difficulties. But so far, we feel that we are on track, and there's still a lot of work to be done before Cagliari, but we think we'll be ready for racing in April.
Explain to us, Martin, the concept. A 75-foot foiling monohull like nothing we've seen before in the Cup. With Luna Rossa as the challengers of record, how close was your design team involved in the development of the class?
We were very closely involved in the development of the class rules and partly in the development of the concept as well, but the first step was to decide together with Team New Zealand what kind of boat it will be, and then writing the class rules together with Team New Zealand. And that was a long process. It took about 6 months, more or less, 6 months, to come out with the first version of the class rules. And it was a lot of work, and we were very closely involved.
I mean, it looks from the outside that it's, when we saw those initial drawings, that it was really sort of far away, the design. I mean, how much did it feel like that at the time, that this was pretty ambitious?
We were confident that it would work, that the concept would work. Before our first meeting with Team New Zealand, they had already worked on the concept, and first calculations had been done. And then they showed us also a version of the boat in their simulator, so we could discuss it with them, see how it works, and test it. And from those simulations, we were, I must say, right from the beginning, very confident that it would work. So I think I can speak for us, and for sure also for Team New Zealand, who worked on that we were not too afraid that it would not work.
So two of the teams, the defender Emirates Team New Zealand and the challenger of record Luna Rossa, have been working together to create the blueprint, if you like, the rules that surround the design and build of the new AC35 class. Working to those rules then are the other two teams that have declared an interest as challengers. The first of whom we talked to being the British Cup interest, INEOS Team UK. Heading up the INEOS design team is New Zealander Nick Holroyd, another Cup veteran, previously with Emirates Team New Zealand, and then in the last Cup with Dean Barker's Japanese challenger. We spoke to Nick at the team base in Portsmouth. Hi Nick, well last time I interviewed you, you were with Team Japan in Bermuda, of course, this time with INEOS in the UK. How are things progressing here at Team INEOS UK?
Progressing. I mean, we're almost halfway through the campaign. Like any America's Cup, you feel like you're running out of time already. It's a fairly young team. We've had to build tools. We've had sort of set up time, and to be fair, we've now got the boat on the water. We're starting to collect useful data. The boat's getting thrown around a little bit more actively. So yeah, I mean we're in the thick of it.
It's a very different boat this time around, the AC35. As a designer with a long history in the America's Cup, how do you approach building a brand new class of boat?
I mean the new class rule is, for me anyway, that those are the fun cups. The stakes are pretty high because I think some people get it right and some people get it wrong. But at the same time, it's a little bit the Wild West of yacht design. Obviously going back to the first foiling cats in San Francisco, new class rule, probably didn't anticipate foiling in the first place. It'll be interesting to see what the developments are that probably weren't anticipated by the rule this time around. Yeah, there's a lot of ground to cover, I think, is the big thing about a new class boat.
We saw with New Zealand's approach to the last Cup, didn't we, how a bold approach can pay serious dividends. How much of what you learned from the last Cup is applicable now?
I think everything you've learnt from every Cup is applicable right now. I mean, you try to bring that with you. I think in a new class of boat, balancing kind of risk assessment versus how far out you want to push things, the creative side. Those are things that come with experience at some level. So yeah, you're desperately trying to apply those to the best of your ability right now.
The fourth Cup team on the roster is, of course, American Magic, the newest team to the world of the America's Cup. Their head of design brings years of high-end yacht design experience to the table. Another previous Emirates Team New Zealand design team member, Marcelina Botin Studio are one of the go-to design teams for high-end yacht design. They've built Volvo Ocean Race yachts and have an established working relationship with the Americans through the design of the championship-winning TP52 Quantum Racing. Hi Marcelina, many thanks for your time doing this. Tell us, how are things going at American Magic?
Well, it's going well. We're sailing in Pensacola at this time, training, and looking forward to do some racing in Cagliari in the next month.
We see in the AC35, Marcelino, a new class of cup boats. Personally, how exciting for you is it to be designing such a radical new design of race boat?
Well, it's a very interesting boats to design for sure. They're extremely fun as a design project, and because obviously it's a new concept, it's a very complex boat in all areas, and for a designer is a really interesting project. As a race boat, I'm not so sure whether it'll be as good as some other classes which we had in the past, but we'll find out soon enough. You know, it's something to be discovered in the next few months, I guess.
How extreme is this design project? I mean, a fully foiling monohull, how radical is that to design and to build?
Well, it's pretty radical. I mean, it's as radical as it gets. I can't think of any other boat that's so extreme in all areas. You know, the foils, the aerodynamics, the structures, the systems, everything has to be taken to the highest level. You know, and you need the best possible people in all areas to design this boat. So it's as radical as it gets, for sure.
So that's the 4 chief designers we'll be talking to throughout the rest of the podcast. We kicked the chat off with a few questions about everyone's thoughts on the 4 designs currently out sailing. And I first asked Team New Zealand's Dan Bernasconi how surprised he was to see 4 very different design interpretations from his original set of design criteria.
I'm thinking back to when we were sort of waiting with anticipation to see other people's yachts, other teams' yachts. I guess we were expecting quite a lot of variation because the rule is quite open, and there's plenty of scope to make different design choices. I mean, even within our own team, we had a lot of different ideas, and in the end we had to pick a hull shape and go with it. So not surprised that there is a lot of variation. Really glad that there is. It's exciting. There's, I think, 2 main camps. There's more similarity between our yacht and Luna Rossa's, and then more similarity between INEOS and American Magic. So there's sort of 2 broad categories, but then significant differences within all 4.
Can you give us an idea of your thoughts on what you've seen of the other 3 boats at all?
Yeah, there's really interesting features in all the yachts. In general, I think we've got a good understanding of why teams will have chosen to go down the paths they have. I mean, there's pros and cons in most aspects of design, and then it's a case of how you weigh up those trade-offs, those pros and those cons, against what you think will be most important in a racing environment in 2021 or in the sort of summer of 2021 in Auckland. So although I think all the teams will understand, you know, why there are different hull shapes out there, and really different hull shapes, it comes down to how you evaluate the relative importance of the lower speed, the takeoff, the aerodynamics, high speed touchdowns, and so on.
I asked Luna Rossa's Martin Fisher the same question. All the teams have now launched an AC35. I mean, there's great footage online. You know, the sailing fans hungry to see that. There are 4 quite different designs, even to the untrained eye, you can see that. How surprised are you at the difference in interpretation from each of the 4 designs?
I'm not so surprised. Actually, I'm happy to see lots of differences, because when we wrote down the rule, we tried to write an open rule that encourages diversity. So it was not expected, but it was a desire to have boats that really look different, and therefore the rule is written in a way such that there are different solutions to the same problem, namely winning the cup. So it is not a straightforward path where to go. So therefore I'm not so surprised that there are so different hull shapes. But in the end, I think, of course they're different, but more or less there are 2 types of hull shapes, and well, that's good to see that. Can you give us an idea of your thoughts on what you've seen on
on the other 3 boats?
Yeah, I think we can split the 4 boats into 2 groups. There's American Magic and INEOS. They came up with very flat hulls, so the bottom of the hull is really flat, and to my understanding, they are looking for righting moment in order to produce lots of power and then get quick onto the foils. Whereas Team New Zealand and us, we went for a hull with a sort of hump at the bottom, and so obviously both of us, we were less looking or less keen to get lots of righting moment, and for us it was more important to reduce the wetted surface when the boat comes out of the water, and so that's one aspect. And then the other aspect is aerodynamics. So the drag of these boats, or the aerodynamic drag of these boats, represents about 50% of the total drag, so aerodynamics are extremely important, and we think that with this hump the aerodynamics is slightly better, because the hull actually creates a so-called end plate effect. So for the sail to work efficiently, it is important to reduce as much the flow of air in between the hull and the water surface. And with this extension of the hull, we close this gap, and therefore we think that our sails work a little bit more efficiently and therefore create more thrust. So there are several aspects, and
There's lots of things to weigh up. I mean, I guess like all aspects of sailing, there's a sort of risk and reward. I mean, what's the risk, I guess, of your thinking about having that kind of hull?
There are risks involved. I must say I don't want to go into detail because if I speak openly about that, I reveal or disclose some of the weak points that we see, which are of course there. And as you say, in every design there's a trade-off between potential gains and potential risks. One risk, of course, that we have with this kind of shape is that these hulls have less righting moment than the flat bottom hulls. So in non-foiling conditions and also during the takeoff phase, we are lacking a bit of power at the beginning, at least. So during the acceleration phase at the beginning, there's less power, but we think we can overcome that. Obviously, INEOS and American Magic, they put more importance to that aspect than us. Well, the future will show who's right. I don't know at the moment.
Before we then hear Team INEOS's thoughts on the comparisons, there's an important footnote to add. The teams have all been busy designing their AC35s according to the AC75 class rule, which was published on March the 29th, 2018. While this stated the rules governing the restrictions on boat design and build, what the teams did not know was the actual wind limits, upper and lower, that the Challenger Series and Cup Match would be raced in. When designing foils for a 75-foot foiling monohull, this information was quite important. But at the time of interview for this podcast, this decision was going through mediation as determined by the America's Cup arbitration panel. The wind limits have actually since been set at a minimum across all competition of 6.5 knots and a maximum of 21 to 23 knots for elements of the Challenger Series and the Cup Match respectively. However, on asking Nick Holroyd for his thoughts on the comparisons and differences between the hull shapes, it's important to note that he still did not know the exact wind limits. Back with Nick at Team INEOS UK. Nick, there's 4 quite different designs out there. How surprised are you at any difference in interpretation from each of the 4 design teams?
I'm not surprised at all, to be honest. There is, and it's kind of levelling out, but there's a certain asymmetry in the America's Cup in terms of information. So Defender, certainly Challenger record, I think, understood the class rule as it was going to be quite a long time before it was released to us. So in some senses, I think if you look at ourselves and American Magic, you probably see perhaps some similarities there, and that aspects of that information asymmetry continue to this day. And I mean, as Team New Zealand have recently put out a press release, I guess I can speak about it, but the absence of match conditions at the appropriate time, and while Team New Zealand focused on the upper wind limit, and that press release, actually the one that's interesting to us is the lower wind limit that we're racing on. It hugely drives the area we put into the foils in terms of getting foiling early, etc. So we obviously we've made our thoughts known to the arbitration panel on those. We'd like to see that resolved quickly because it does drive the design process. The fact that we're all in different corners right now, not surprising at all. Will we likely see things converge quite rapidly in the second generation? Yes. And then ultimately, the question remains: is this a hardware or a software race by the end of the match?
Can you give us an idea of your thoughts on what you've seen of the other three boats?
The Kiwi boat is clearly very well thought out and quite a coherent design. Again, in light of the discussion that's happening with the arbitration panel, has focused quite heavily in the sort of light air early takeoff corner. Ourselves in American Magic, I think, were assuming actually lighter airs again, that we would have to run in displacement mode at some point. And then the Italians have kind of probably cut out, I think, that very light air corner altogether. So yeah, very different interpretations. And I think we will see convergence pretty quickly.
When you're designing something which is so finessed, which is looking for the minutiae of improvement, I mean, how tough is it not knowing where the wind limits are, where the parameters are?
I mean, that's a really big thing, and it's driven. Why it's such a big thing is because it's driven by lead times for the components. The foils are complex; they take a long time to build. It's probably no secret we're already building our boat too. And so you are making decisions slightly in a vacuum. To some extent, you look at the people who have the power in the situation, which is probably the defender first and foremost, and you look at the type of game you think they've designed their yacht for, and at this stage we probably have to operate on looking at making assumptions on where they've gone and following down that path.
We've seen two boats with a more shaped hull. Yourselves and the Americans have a much flatter hull. What's your thinking behind this choice?
I think it's, as I just mentioned, it's in relation to whether you ever expected the hulls to perform in a displacement mode or not. As I say, ourselves and the Americans are probably operating from very similar information backgrounds, and the other two are somewhere else.
Perhaps just explain to us the benefits of having a flatter hull when you're flying.
Ultimately, we're talking about the boat as a fuselage once we're flying, right? So we're interested at that point in how the boat impacts the aerodynamic efficiency of the rig, how well it hides the crew from windage, etc., etc. If you're looking at the boat as a displacement boat, I think you end up in one corner. If you're looking at the boat purely as a early takeoff launch vehicle, because you will only be racing in enough breeze to be in that sector, then you end up with a dichotomy.
We're back with Marcelino at American Magic. Marcelino, we've all seen the four designs out there right now. How surprised are you at any difference in interpretation from each of the four design teams?
I'm not so surprised by the new concepts. Some are pretty different from ours, but it's not a big surprise what we've seen. What it is a little bit more surprising is the level of development of some of the teams, because I guess our philosophy was to, or our idea was to get the boat the first boat in the water as soon as possible and not dedicate too much work to the details of that first boat. However, some of the boats that we've seen have a lot of detailing in the design, and from that point of view, I mean, for us it didn't work at the end because of the delays with the foil arms, but our idea was to get the boat as soon as possible and concentrate as soon as possible on the second boat.
Can you comment at all on your thoughts regarding what you've seen of the other three boats?
Yeah, well, it's hard to comment at this early stage, but it does seem that this different, especially with the hull shapes, there's different philosophies. There's INEOS and American Magic, which are similar in the hull shapes. Not so much on other details, but at least in the underwater part of the hull shapes, they're similar. The other two teams are a little bit less stability, less form stability with the hull shapes, but aerodynamically also they're quite different.
Why has that happened?
Well, I'm not sure. I mean, obviously, the teams have their own way of dealing with the problem. I mean, it's hard to tell.
We've seen two boats with a more shaped hull. American Magic are running a much flatter hull shape. What are the design choices that result in this flat hull choice?
Well, it provides a little bit more form stability for the hulls, and when the boats are in non-displacement mode, it's a good template for the aerodynamic efficiency of the platform. So those were the main two driving factors behind that sort of boat.
You really have to make some pretty difficult decisions about how you're going to weigh up the different areas of performance.
You want to democratize the data. You don't want it held in the hands of analysts.
So that's the team's thoughts on where things are heading to date. My next question was to Dan Bernasconi and relates to an area of design that has been widely credited as a vital part of New Zealand's win in Bermuda back in 2017. Dan, the teams all seem to have come out with a degree of foiling ability on their first builds. How much is that down to simulation use, do you think? I mean, the simulator you had during the build for the last Cup, of course, heralded as one of the team's big strengths. How much simulation is going into these AC35s?
Well, the whole class was developed with using just a simulator. So although the first sketches were on paper, it quickly developed into simulator models of all the different concepts that we were evaluating for the AC75 class, all sorts of different types of foiling and displacement boats. And I think without the simulator, we never would have had the confidence to go ahead with this pretty radical class of yacht without having built a prototype. So yeah, really important in the conceptual phase, but then just like in the last Cup, and even more so really, the simulation is becoming an ever more important part of design. Pretty much everything that we design in terms of performance aspects of the yacht, sails, in hull shapes, in foils, rudders, all goes through a simulation process. And I think what's really cool about that is it really connects the design team with the sailing team. So designers need sailors in order to sail the simulator and basically to tell them whether a design is fast or not, because ultimately it comes down to a lap time. So the discussion and the conversation about what a better foil or what a better hull shape might be, or what the trade-offs of those things are, it is really enabled by the simulator, and there's such a good working relationship between sailors and designers when they sit down in the simulator room for a few days coming up to say a full design deadline, where we can really all learn together about the various characteristics of the foils we're looking at.
Having set the design criteria, Dan, what do you see as the biggest challenge in designing a winning AC75?
I think there's a few things. I mean, first of all, it's a really complex boat, and you've got to get around the track. There's a huge number of electronic and hydraulic components on the yacht, and some pretty complicated mechanical systems. So I think inevitably in the first World Series races in Cagliari, I'd be very surprised if there aren't some races won or lost through mechanical breakdown. But I think by the time we get to the Prada Cup and the America's Cup in Auckland in 2021, then maybe there'll be the occasional issue, but touch wood, the races will be decided mainly on performance. And then I think it's a really difficult question because it's such an interesting boat in terms of design trade-offs. You really have to make some pretty difficult decisions about how you're going to weigh up the different areas of performance: light wind, speed, light wind, heavy wind, upwind, downwind, takeoff versus straight line versus manoeuvres. There is not one boat which will be best at all of those categories together. So there's some pretty difficult decisions to be made around how to balance those trade-offs, what you're going to focus on, trying to get the best compromise. And ultimately there might be a bit of luck, because if one team designs a boat for lighter breeze and the Cup ends up being in lighter breeze, then they've got an advantage.
Plenty of decisions to be made then. But one of the key elements in this design, of course, is that the AC75 is at some point going to shift from being in displacement mode a la traditional monohull to foiling mode. And as this transition takes place, it brings with it a host of new design decisions. A question I put to Luna Rossa's Martin Fisher. In the hope that the hulls will be flying much of the time, I mean, how much more is the hull design influenced by aerodynamic rather than hydrodynamic decisions?
It's on par, it's equal. The aerodynamics of the hull play an important role, of course, during during the takeoff phase, or if you have a crash, if the boat drops and you have to restart again, then the hydrodynamics are very important. But once you are foiling, obviously the hydrodynamics of the hull no longer count. There's no importance of that, and then it's only aerodynamics. So during the development, we put as much emphasis on aerodynamics as on hydrodynamics. We worked really full on both aspects because we think they're equally important.
Marcelino from American Magic, can you compare for us the balance, the payoffs, if you like, between maximum aero or hydrodynamic efficiency? I mean, obviously the hulls are designed to fly above the water as much as possible. So which is more important to the design of American Magic?
Well, we're clearly not counting on having to sail these boats in displacement mode a lot. So the aerodynamics is much more important than the hydro. That's pretty clear. Now the hydro also is important, especially for the takeoffs, and if you do some displacement sailing, obviously it's got some relevance. But we were talking about that here in the office the other day, and it's one of those things that you wouldn't have imagined not too many years ago. A boat that can sail at 40 knots. It's not even touching the water with the hulls. That's something pretty amazing.
I then put a similar question to INEOS's Nick Holroyd. How important has aerodynamics in design become in a world where hydrodynamics has obviously been king?
When it's one half of our balance sheet, if you like, it's the drive force, half of the equation, and you can't afford to ignore it for a second. Sail aerodynamics are hard. It's flying shapes, not really knowing exact shapes, etc. So yeah, it is roughly half of our total effort. Actually, it's a huge part of the whole design thing. The boats, will evolve, I think, to having ultimately, when foiling very similar wetted surface areas, etc., the subtleties of how you're using that wetted surface area, will clearly evolve and pay dividends and bias certain boats uprange or downrange or upwind, downwind, etc. But the sail plan is always there. And the second thing is the measurement protocols for this coming cup are somewhat different to the last two. So we've been used to being able to modify on a daily basis, choose foils for uprange or downrange or what have you. This time we are going to be obliged to do the measurement certificate 5 days prior to the cup. So it's about the limit of forecastable weather in Auckland. Moves through there pretty quickly. And then we have to keep that configuration through the remainder of the cup. And so actually your moding tools become aerodynamic rather than hydrodynamic. So you start to look at the sail plan, obviously, and how we could mode the boat against opposition if we see them as being strong or weak in certain places.
With that in mind, Nick, the team have recently announced a partnership with Formula One team Mercedes AMG Petronas. We often see announcements like this around the Cup, but they have a huge design pedigree and obviously a massive knowledge base when it comes to aero design. What is this collaboration bringing to the design team here?
I've been involved in sort of technical partnerships, I guess, across however many Cups over 20 years. And this is head and shoulders above anything we've ever worked in. So yes, they have enormous resource. We have roughly 15 embedded engineers in our process. We have access to specialties that we wouldn't normally have access to. So we break something and we can go to a metallurgist in their gearbox division and find out. So the kind of breadth that brings in is huge. For me personally, working, being able to sit there and watch guys like James Allison work, and a kind of steering group mentoring system they bring with them is fascinating. So look, it's specifically areas they're working on, helping us with simulation, as you mentioned, helping us with aerodynamics. There is a pretty steep learning curve from their side in terms of kind of the domain-specific knowledge about how we run our VPPs and kind of what the performance drivers are in the marine side, because they are actually quite different to a car. So yeah, look, it's been an absolute pleasure to bring them in. Amazing organisation culturally, in terms of, to a man, the people we've had here, the absence of ego and stuff has been remarkable to work with.
Obviously, data analysis is also a huge part of Formula One, but last time around, this team were running a pretty comprehensive remote data analysis system. The flight deck saw the team tracking data off the boat live while sailing. Can you give us a sense of how much data is being analysed and how important this part of the process is?
It is, we again, by rules and protocol, are prevented from doing any testing in kind of a closed environment. So wind tunnels, towing tanks, etc., are all off the menu for us. So that forces your whole working paradigm into the computational domain. So lots of CFD and simulation work. And obviously we take design candidates, we run them through those tools, we go to the human in the loop simulator, we run them there, we take them out on the water, the guys give us feedback, etc. But essentially that analysis of what's happening on the water, what we're seeing there, are we achieving what the tools tell us, is such a critical part of the loop, because ultimately you're reliant on those tools to drive the next loop of design, innovation and iteration, right? And so there's two things you need from those tools. One is kind of fidelity. They've got to give you the right answer, otherwise they start pushing you in wrong directions. And the second thing, and that's been something we've worked really hard on this time around, is they've got to be productive. You've got to be able to kind of work through and crank the handle and do those design iterations really carefully. In terms of the data feeds and what have you, to be fair, I probably have more situational awareness of what's happening on the boat, sitting at my desk, watching all the camera feeds, and listening to the comms on board the boat. I can hear the tone of Ben's voice, whether he's pissed with something or otherwise. And yet I can still get a day's work done and drive the process. So yeah, those are hugely enabling technologies. And it means, exactly, I can sit here, obviously we're building boats and foils and what have you, and that's driven from here in Canberra. The boat's down in Cagliari, and I can join a debrief meeting at 4 o'clock this afternoon and contribute to that in some meaningful way.
The last cup, obviously, the information all came to a rib, and the rib chased the boat around at 40 knots around the Great Sound of Bermuda. Perhaps just explain, the advancement in the process now and simply how it works.
I mean, it is the same thing essentially. We have all the boats out there on a mesh network that so they can all see data in very live time. That structural engineers need that in obviously real time to be monitoring alarms and understanding what's happening on board from a safety aspect. And then once it's on that mesh network, it's essentially across 4G networks or 5G networks back to the main infrastructure and back here. Then once it's in here, one of the tools we started really early and have built up is you want to democratize the data. You don't want it held in the hands of analysts specifically. You want that anyone can come in, open a web browser, click on a link for a day's sailing, choose what channels of information they're particularly interested in, which video views and what have you, and be presented with this kind of time-synced dashboard of what's happening out there in a really sort of seamless way. And then you want to be able to communicate that around the team. So I see something interesting that I want to communicate to the foil guys. I want to just be able to go, here's a web link, click on this, and tell me what you think. So all of those aspects of how you run the data, how you make it accessible, and ultimately how you use it to drive the sort of integrity of the design process are key.
Throughout various filming sorties in the build-up to the last Cup in 2017, I spent a lot of time out on the water with several of the teams. Much of that time in ribs full of design team members, away from their desks, on station to oversee data gathering, answer questions, and help fix any issues. So I put it to Dan Bernasconi that the now widespread use of real-time live data analysis, which Team New Zealand are also running in Auckland, must be a huge step forward in design team efficiency.
Yeah, what the big changes for this campaign is being able to stream the video and data live back to all the guys on the shore. So, it's a long day on the water. Like yesterday we were out on the water for about 9 hours, and so if you're a designer interested in what's happening for maybe 1 hour of testing within that 9 hour period, in the last campaign you'd have been out on the water for the whole day, and it's crucial that you're there, but it's pretty inefficient in terms of getting a day's work done. So with 5G we were able to stream all that data and video live back to the guys on the shore, and so they can just switch on and tune in for the bit of testing that's relevant to their area of design. And in terms of what we're analysing live, we're trying to get more and more live data analysis. Traditionally we would always have debriefs, and you go sailing and then you come in from a day's sailing and the sailing team sit with the design team and go through the data. But I think the more immediate feedback you can give, the more valuable it is. So it's valuable if you can say to them several hours later, oh, remember that tack there, this is what happened. Whereas if you can give that feedback sort of straight whilst the tack's happening or straight after the tack, it's a lot more useful, and I think it accelerates the learning curve a lot.
And then regarding the class rule itself, we've not seen monohulls in the Cup since 2007. So there's been a huge amount of development in multi-hulls in the last decade. And then, of course, massive steps in foiling and all that that's brought with it. How transferable then is what you've learned up to 2017 in what you're designing now?
Yeah, traditionally in the America's Cup, a team that has won and gone on to defend that cup has usually chosen a class which is very similar to the previous class, because they believe that they're the team which is strongest in that type of boat, and they've got the best design ideas for that type of boat. I think what we believed as a team was that our strength was in innovation and in using simulation. So being able to design a yacht to meet a new set of rules and a new concept. So although the yacht itself is quite different, pretty much all of the technology we use to design that yacht, in terms of hydrodynamics, aerodynamics, foil design, structural design, materials, particularly the carbon composite materials, all the solid modelling technology and the simulator is all very, very transferable. So although the yacht looks completely different, it's very much the same bunch of people designing the yacht, and I wouldn't want anybody else from the guys we've got, because the experience we have in the design team is absolutely phenomenal, and I think what they excel at is applying their experience and creativity to a different type of design problem.
Looking into the variation in hull design that's prevalent across the 4 AC75s, one concept that comes to the fore has to be that of end plating. It's a key efficiency driver in the design of the areas around the hull. So I put it to our designers to explain the concept and to explain just how end plating will manifest itself in the designs we've already seen. First up, Luna Rossa's Martin Fisher.
If a wing creates a lift or a sail, a side force, then you have on one side you have high pressure, and on the other side, on the leeward side, you have low pressure. And obviously air wants to flow from high pressure to low pressure, and at the top and at the bottom there's nothing that prevents the air to flow from the high pressure side, so from the windward side, to the low pressure side on the leeward side. And this flow of air represents a big loss in efficiency. So if you do nothing, so if you leave a big gap at the bottom of the sail, then roughly the first 2-3 meters of a big sail, maybe even more, basically create no force and no thrust. They just produce drag. And if you close that gap, so if you make sure that the air cannot flow from the high pressure side to the low pressure side, then also this lower part of the sail works very efficiently, and you gain a lot in terms of force produced by the sail, and obviously thrust, so forward force that accelerates the boat. And the second aspect is that if the lower part works efficiently, then the center of effort is further down, and so for the same heeling moment of the boat, you can create even more sail force, and you gain even more. So there are two aspects why this is so important. One is the efficiency of the sail, and the other one is that the center of effort of the sail comes further down.
When we talk about the hull designs, you also talk about end plating. So perhaps, give us just explain to us, I guess, the thoughts about the end plating with the hull.
Mm-hmm. At the bottom of or underneath the sail, there sits the hull, and all the teams have a sail that goes all the way down to the deck. But then, so there's no airflow between the sail and the deck, but the air can still flow around the hull, underneath the hull, and then to the other side, and again destroy the efficiency, or not destroy, but reduce the efficiency of the mainsail. And by sailing very low, such that the gap between the water surface and the hull becomes as small as possible, we can reduce this through flow to a minimum, and therefore improve the end plate effect. And with our hump at the bottom, we close this gap even further, and therefore minimize the through flow and maximize the end plate effect.
I then asked Nick Holroyd just why end plating is such an important concept.
If you achieve perfect end plating, we talk about the effective span of the rig. So if I took the rig half a mile into the air, and the rig's 25 metres high, give or take a little bit, then it would look like a 25 metre wing. If I could effectively set that rig up 1 millimetre off the water surface and treat the water surface as a perfect end plate, in a mathematical sense, what you would see is more or less a reflection of the rig under the water. And so we have this 25 metre rig on the air side, if you like, and a reflection of it below the water. And so now aerodynamically I'm seeing a rig that has twice the span. And if we think aerodynamically of aircraft that try to be super efficient, we see really high span. So if we go to a competition glider or something like that, we see this enormous wingspan. So the end plating is a way that we can increase the span of the rig artificially, if you like, and make it more efficient. So that's why we're all playing with it.
For the sailing fan, watching the bits of video we get of the boats, I mean, what would we see? What effects would we see? What would have been done to the boat to encourage end plating?
Well, you will see for sure, I think, and we've been doing this forever and a day with jibs, right? You never leave a gap between the bottom of your jib and the foredeck. Okay, so the foredeck in that case is the end plate for the jib. Here we're probably going a step further in that we'll see the complete rig end plated to the boat, so seal on both jib and mainsail. So now you've effectively connected the lifting surfaces, the ones with camber, etc., the sails, down to the hull. Okay, well I've got that part of the end plate going, and then you're looking at what are people doing to the design of the boat to try and get a connection from the boat to the water surface, and I think we're seeing some quite different solutions out there.
With a flatter hull, which you have, how important is end plating the underside of the hull as well as the top side?
In all cases it's important. If the hull as an end plate is bigger, more effective, then the gain from further end plating it to the water will be smaller or less effective. And I think that's probably the difference you see across the fleet to some degree.
Talking about the concept of end plating, Marcelino, with American Magic's flatter hull design, how important is the end plating of the underside of the hull? And how would you be looking to achieve this?
Well, it's clearly important, and but there's many ways to achieve this, and unfortunately, it's not one of those things that I can really comment too much about. Maybe if you do this interview in a few months, I could give you more details, but it is something that we look at pretty closely, how to end plate the whole aero package and make it more efficient. That's clearly one of the main objectives of the design of the hull surface. Yeah.
Just explain to us why it is so important, and I guess what the payoffs are. What's the risk and rewards of it all?
Well, it's important because you get a more efficient for more efficient sail plane, and therefore more driving force with less drag. So that's why it's efficient. You get a faster boat, and basically that's what you're trying to achieve with a more efficient aerodynamic package.
We're used to talking about end plating, above the deck, in terms of the sail plan, but not necessarily so much underneath. How much relevance is it there, and how difficult has it been to design for that?
Well, on a conventional boat, the water surface is your end plate. So obviously you try to close the gap between the sail and the deck, because you already have an end plate below that. So you don't need to work on that as an end plate. On this boat, obviously they're flying above the water, so there's a gap underneath the boat, which obviously you would like to close if possible.
What are the other key factors that have led you to the specific hull shape that you've come up with in Boat 1?
As I said before, our thinking was originally that we wanted a boat that could perform well, but the idea originally was to have a boat that was simple, easy to sail for the crew, reliable, and that would be a good learning curve. The performance was not such a big driver, because obviously we gave ourselves very little time to come up with this boat. And yeah, as I say, the main objective was as a good learning platform. That was really what we really wanted to achieve. Obviously, with the second boat, it's a different story. Performance is going to be everything. So the time we dedicated to that design was much more geared to performance than with the first boat.
So that is where we're going to wrap up the first edition of our AC design discussion. I hope you agree it's been an absolutely fascinating glimpse into the very secretive world of America's Cup design. Part 2 of the discussion, which we'll be posting online in a day or so, will dig a lot deeper as we discuss the nuances of foil design, the differences in each team's current setup, sail design, the rules regarding power generation, and what our 4 designers think we'll see as each team launches their second AC35 Cup boat. It's a fascinating listen. I cannot go without saying a massive thank you to all 4 of our designers. Thank you so much to each of you for all of your time in doing this podcast. It's massively appreciated. But thank you also to everyone that helped make the remote interviews happen. To Hamish Hooper in Auckland, a big thank you, Hamish, you're a legend. And to Will Ricketson at American Magic for helping do the interview with Marcelina for us. And of course, a bigger than normal thanks to the ever diligent Tim at Vertigo Films for taking on the massive workload of this 4-person podcast, putting it all together and making it all make sense. You're a star. That's it for this pod, but do tune in to part 2. It's another fascinating discussion of some of the real intricacies of the AC75. If you'll be watching the racing unfold throughout the coming months, it's a compelling and unmissable listen. Thanks again for listening. Sail safe, everyone.